In today's lesson, we're going to look at solving investment portfolio problems. Basically, we're putting everything together that we've learned in this unit and building portfolios or analyzing somebody else's portfolio. An investment portfolio is one or more investments held by an individual, investor, or by a financial organization. Let's take a look at example 1 to see what an investment portfolio might look like. Phyllis started to build an investment portfolio for her retirement. She purchased a $500 CSB at the end of each year for 10 years. The first 5 CSBs earned a fixed rate of 4.2% compounded annually. The next 5 CSBs earned a fixed rate of 4.6% compounded annually. 3 years ago, she also purchased a $4,000 GIC that earned 6% compounded monthly. The question we're being asked is, what is the value of Phyllis's portfolio 10 years after she started to invest? So, let's first have a look at the CSBs. Now, use all 3 of these forms for the CSBs. The first 5 CSBs go in this first column, and then it's going to sit for 5 years, so we have to see what happens then, and then there's another 5 that she's purchasing. And then below here, we'll do the GIC, and then we'll put it all together. And that's really what a portfolio is, just multiple types of investments and then putting all the information together. So, how do we do the first 5 CSBs? So she started to build the investment. She purchased a $500 CSB at the end of each year for 10 years. So if it's at the end of each year for 10 years, that's telling me that this is a payment. So I'm going to put 0 in PV, put in my $500 here, each year for 5 years. So each year is PY, and 5 years tells me that this is going to be 5 times PY. Now it's a fixed rate of 4.2% compounded annually. We want to know what is her future value here. Put all this into TVM Solver, and you get an answer of $2,719.01. Now, it sits for 5 years. It says the next 5 CSBs earned a fixed rate of 4.6 compounded annually. 3 years ago, she also purchased a $4,000 GIC that earned 6% compounded monthly. So the sitting for 5 years is taking this value and putting it in for PV. Right? She didn't continually put money into it, but she didn't take anything out either. She just left it there. And by leaving it there, she's not adding to her annual payments, but we can leave how much she made, put it in as a negative, $2,719.01, at the same rate of 4.2 for 5 years. And because this is PV, my PY is 1, PMT is 0. And it's still going to be compounded annually. So, for these first 5 CSBs, the future value then is $3,340.02 after you put that into your TVM Solver. Now, she purchased a $500 CSB at the end of each year for 10 years, so that was the first 10 years we have here. But then the next 5 CSBs earned a fixed rate of 4.6 compounded annually. So here, for the next 5 CSBs, that's 4.6%. PV is 0. We're putting in $500, and we're doing annual payments, compounded annually. So this means this is 5 times 1, future value here would be $2,740.83. So that's the CSBs done. Now let's go ahead and have a look at the GIC. It says here, 3 years ago she also purchased a $4,000 GIC that earned 6% compounded monthly. So if we're putting this in, this is a PV because she's not making regular payments. It's one lump sum, so I know that I put that as 1 and PMT is 0. 6% compounded monthly. So here's a situation where PY and CY are not the same. Be careful because sometimes the calculator automatically puts those in as the same. We want to know for 3 years what is our future value. And then times it by 1 because that's PY, not CY when you're figuring out N. Putting that in TVM Solver, you get $4,786.72. Now the question asks, what is the value of her portfolio? So the value of her portfolio would be finding the total of all of our investments. But what am I actually adding up? The only values I'm going to be adding up are the future value of her GIC, the future value of her first 5 CSBs, recognizing that that's the answer. We need both of those together, right? Meaning both of these together. And then the next 5 CSBs is this value. So those are the 3 values that I'm going to be adding together. Putting all that in your calculator, finding the sum, you get, with a $sign because this is my final answer, $10,867.57. Make sure your $sign goes at the beginning of your number and you have two decimal places there. Part B of this question says, Phyllis found a savings account that earned 4.9% compounded semi-annually. She redeemed her portfolio because interest rates went up and invested all the money in the savings account. About how long will it take for her to double all of her money? Now, some key information here. About how long, so we're figuring out the time, about how long will it take for her money to double? This is an indicator for us to use the rule of 72. Alright, so rule of 72 tells us to take the interest rate, 72 divided by that, as a percent, not as a decimal place, and that'll give you your time. So in this case, that would be 72 divided by 4.9. Punch that into your calculator, you get 14.694, and so on. What does that mean for us? Well, that means that it will only take about 14.7 years semi-annually. We have one other example that we're going to look at for this last lesson in this unit, and this is a much bigger portfolio. It says Jason and Malik are each hoping to buy a house in 10 years. They want their money to grow so they can make a substantial down payment. Now, we've got they're both of their portfolios, and if you look at the next page, we've got some space here to organize it, and actually goes over to the next couple of pages, because once we're done and we find the interest earned, we also want to look at the rate of returns for each of their portfolios and see what does that look like for each of these 2 people. So if we look at Jason's portfolio first, we're just going to go through that, and then we'll go through and do Malik's portfolio again. So it says a 10-year $2,000 GIC that earns 4.2% compounded semi-annually. He's got a savings account that earns 1.8% compounded weekly, where he saves $55 every week, and a 5-year $4,000 bond that earns 3.9% compounded quarterly, which he'll reinvest in another bond at an interest rate of 4.1%. It's important to understand that most people don't just have one investment. They usually have multiple investments, or the portfolio that they're investing in is multiple investments, right? Because you can also buy into or invest into a portfolio. So looking at this, let's start filling in the information. Now it's important that we see that it says he'll reinvest in another bond at an interest rate of 4.1%. So we're going to have some extra information that we're going to be needing there. Let's start filling this out. Now, total invested at the top here, we're looking at how he's invested into each of these, right? So really what we're looking at is the principal. Now for the GIC was one lump sum, and that was $2,000. Savings was $55 that he was putting in. I'm not going to use the dollar sign just so we don't get confused. $55 weekly, right? And if we go back, what was that for? So $55 every week, and this is for 10 years, right? So $55 each week for 10 years. Punching that into your calculators, you should get $28,600. And then finally that bond, which has a value of $4,000. Now it is being reinvested, but that's how much he's initially putting in. So if we add all of those up, we get a total that he's invested, which is $34,600. Now this is really important, especially for when we're figuring out the rate of return, because our rate of return is the interest earned over the total invested. So right now we figured out the total invested, but we don't know what the interest earned is. We have to still figure that out. So let's start with the GIC. And I'm just going to put this on the side here, so I know that this first part is the GIC. Now the GIC we saw was one lump sum of $2,000. Oops. So we're not putting regular payments in there. We're going to put 1. This is for 10 years times 1, compounded semi-annually, twice a year, at a rate of 4.2%. Future value is what we're solving for. Punching that into your calculator, you get a future value of $3,030.71. Next, we're going to look at the savings. So in the savings, if we go back to the other page here, savings account that earns 1.8% compounded weekly, where he saves $55 every week. So it's safe to assume that that's going to go into PMT for when we're saving every week. So that means he's putting money in each week. Regular weekly payments. So that means that this goes in as a negative 55. P/Y is going to be 52, because that's weekly, and it's also compounded weekly, so that goes in as 52. When we do that, we use 0 for PV, and our N is going to be 10 years times 52 weeks, so that's the total number of payments that are made at 1.8%. Punching that into TVM Solver, we get a future value of $31,329.72. So far, that's the future value if you add those together of our whole portfolio. But there's one extra thing, one extra investment that he makes, and this investment is into a CSB. It's also reinvested. So we're going to put CSB in twice. So when you're organizing your work, you're probably going to want to put another one of these besides, so you can see what happens when the money is reinvested. Alright, so 5-year $4,000 bonds that earns 3.9% compounded quarterly, which he'll reinvest and another bond at an interest rate of 4.1%. So what does that look like when we put this into TVM? So let's look at our first 5 years, and then the next 5 years. So for the first 5 years, that would be 5. It's one lump sum of $4,000. So PY is 1, so this would be times 1. No regular payments. At an interest rate of 3.9%, compounded quarterly. Doing that, you get a future value of $4,856.65. Now this is reinvested, so we're going to put that in here as a negative $4,856.65. Remember, because it's our money that we're investing, we put that in as a negative. And again, because it's a lump sum, this is 1 for 5 years, so times 1, but at a different interest rate. Now this interest rate is 4.1%, and this is compounded quarterly. Doing that, we get a future value of $5,955.44. Now I'm saving us I'm saving us time by not punching everything into the TVM solver, but it's really good practice to do that. Just watching me write these numbers out isn't enough. You should be typing those in and making sure that you're getting the same answers that I'm getting in your TVM solver. Alright, let's find the total portfolio. So what we're doing is we're going to add those 3 values together, and doing that, you get you get more than that, $40,315.87. Now that's just one person's portfolio. They're asking us to compare that to Malik's portfolio, and then to go ahead and figure out the rate of returns. So I'm going to continue with Jason onto the next page to find the interest earned and the rate of return, and then we'll go back and do this other portfolio. So how do I figure out the interest earned? Well, the interest earned is going to be the future value, the amount that we've got at the end, minus our principal. Now our principal in this case is the amount of money we've initially invested. Okay, so I'm getting the principal from this value here, and the principal there, and then I'm going to get the total portfolio value here, and that's what I'm going to be using as A to solve for the interest earned. So doing that, would be $40,315.87 minus the $34,600 to get $5,715.87 in interest. To figure out a rate of return, that's our interest earned divided by the total invested times 100%. So those are the values that we have here, 5,715.87 divided by 34,600 times 100%. That gives us a rate of return of 16.5%. Now, doing this all over with this other portfolio. Now what I'm going to ask you to do is I'm going to ask you to go ahead and do Malik's on your own, and then come back to the video and check to see that you're getting the same answers as me. Every portfolio that you're going to receive is going to be a little bit different, but the general guidelines for how you're doing it is going to stay the same. You're going to start with the total invested, so how much is that? Look at each individual investment, get the rate of return at the end after finding the total portfolio cost. Alright, go ahead and try that out. Taking a look at Malik's portfolio, you should get a total invested of $34,600, which actually is the same amount that Jason's portfolio was when we looked at how much he invested. So let's see how, once we go through each individual investment, how the rate of return is going to compare. Having a look at Malik's TFSA, we see that she has a future value of $6,976.62. Next, let's look at her CSB. The CSB earns $5,892.88. And finally, Malik's savings, she earned $26,007.87. Putting those three values together, adding that up to get our total portfolio, we can see that Malik has a total portfolio value of $38,877.37. So looking at her total portfolio and comparing it to Jason's total portfolio, we can see that the rate of returns are going to be different, even though that the amount that they invested was the same. Let's go ahead and calculate Malik's rate of return. So initially we have to figure out the interest that she's earned. Same calculation as before, we're going to take our future value minus the amount she's invested. In her case, $38,877.37 minus $34,600 to give us $4,277.37 invested. To get her rate of return, we take that value we just calculated, divided by the $34,600 times 100%, we get a rate of return of 12.4%. So in the end, we can see that Jason has a better rate of return. He's making more interest than Malik in those 10 years. Just in summary, the rate of return compares investment portfolios, and that's the formula we used. Investments that involve greater principal amounts invested or greater regular payment amounts when contracted tend to offer higher interest rates. The factors that contribute to a higher rate of return are time, interest rate, and compounding and payment frequency. That's it for this lesson, and that's it for this unit. Thanks for joining me.